Science and Math building. So we're looking forward to another great discussion. The previous Charrettes. We will pretty much follow the same agenda, and Michael Aiken from the Link Public Strategy will give you more details on that in a second. I want to recognize some VIPs in the audience tonight. Mayor Kate Stewart from the City of Takoma Park is there. Peter Polar, council member from Takoma Park, Ward 1, in the room. Bob Levy from Montgomery College Board of Trustees is back there in the corner. Did I miss anybody? If you think you're a VIP,
well, I'm not a VIP, but I'm from the agency. I'm from the Montgomery College Department. My name is Laura.
Hi, Laura. Thanks for coming. I appreciate it. I was looking for Gwen, but I didn't see her.
She might be coming.
Oh, okay. Thank you. Please do my cameraman a favor when you're walking around tonight and duck if you walk in front of him so that we don't have blackouts on the video that we put up on the web page. And that brings me to a segue here. If you need any information about what happens in any of the charrettes, you can find it on the web page. Go to MC Blogs about the Leggett building and everything. All of the PowerPoints are up there. The videos are all up there. The answers to all the questions you ask us are up there as well. So please track our progress on that document. And with that, I'll introduce. Are the results of the geotechnical study going to be? We haven't got it yet, have we?
It's still under review.
Okay, still under review. So it'll be up there as soon as we can. Okay, thank you. Okay. So Michael Aiken from the Link Strategy.
Hello, everyone. Good evening. Good evening. This is our, third meeting together, fourth meeting together, fourth time we've come together. We're going to run tonight, much like we've run the other meetings. We're going to spend some time together in here, getting a riveting presentation from our architecture team. If you thought last time's 100 slides were great, just wait until you see tonight's 100 slides. It just keeps getting better. What we're going to do tonight is learn together what we heard from each other at our last meeting, how that has driven some of the design changes that you'll see tonight. And then we're going to break up into small groups like we did in the past, and we'll take questions, we'll give comments and answers, etc., and see if we can continue refining until we get to a product that we're all happy with. So that's the general format that we're going to use tonight. Next slide. So for some of you that are coming in to this process new or just need a little refresher, I'm going to walk through what we heard in some of the past meetings and go from there. Next slide. So this was our last meeting on September 11th. Look at those faces. Everyone's so serious and engaged. We're going to have that same format tonight. These are the types of questions that we got and comments that we got. There were nearly 100 comments received at our last series. All of them, as well as the responses to each of them, are posted in the hallway. We don't expect you to be able to read that, but in the hallway, they're blown up and you'll be able to see every comment, question, and response. They're all also going to be on the Montgomery College website as of tomorrow, so you can find all of these and print them out as well. Every single thing that's been raised has been recorded and responded to. So that is the feedback. If we go to the next slide, we'll take you back to the very beginning of this process, again, for a quick refresher. At our first meeting, all of the feedback collected from that, and it was hundreds of comments, boiled down to kind of 5 key themes. We needed some additional clarity to be provided around the engagement process and how your feedback at each stage would be used in the process going forward. There was a lot raised around environmental considerations. That was not just how the building would be environmentally friendly, but how the construction process itself would manage some of the environmental issues related to it. There were lots of comments, questions around the design elements of the building. Internal considerations became that catch-all group for the things about the internal operations of the building. This is where students asked questions about how the labs would support teaching and learning. It's where faculty members asked about how office space in the building would be decided. It was everything internal, fell into that category. And then last but not least, we heard at our first meeting questions and concerns around construction itself, and when we actually start building the building, how will the impacts of that be mitigated? In our second meeting, the feedback, again, a few more hundred comments were analyzed, and they kind of fell into, if you go back one slide, it fell into these categories. So we heard very clearly that we wanted to explore things that broke down the massing in the building. If you remember, in our second meeting, we looked at 3 different options, and we really heard feedback that people wanted the massing broken down more along what they were seeing in concepts 2 and 3 than what they saw in concept 1. They wanted us to take a deeper look at pedestrian and vehicular traffic flows to and from the site, minimize noise generated by the building, and also minimize light trespass from the building to the surrounding residential neighborhood. Active communication and accountability during construction, and then finally, how are we preserving and protecting the existing trees on the site? So we spent a lot of time at our last meeting talking about all of those. And then finally, this is what we heard at our last meeting together on 9/11, as well as in the feedback we received since then. There was an overwhelming preference for the lower height in concepts 2 and 2.5. There was a preference for the setbacks in 2 and 2.5. And if you're not sensing the theme already, there was a general preference for 2 and 2.5 versus the third option that was up there. So you'll be seeing some more iterations of those 2 tonight. We also heard some pretty good feedback and pretty vocal feedback around making sure that the building design overall takes into account not just the context of the campus, but the context of the surrounding neighborhood, to make sure the building materials, the look and the feel of the outside of the building really takes in that larger context. And you'll see what the architecture folks have done with that tonight. So before I turn this over to Bob, let me just remind you we're in kind of stage 4 of a 5-stage process, so we're making some really good progress together. I do want to highlight that we have another meeting coming up on October 16th, but I don't want to understate the fact that this process has been moving along. So if there's something you've been holding inside that you really wanted to make sure we know, tonight would be the meeting to let us know that, or in an email or a phone call in the near future, because we are moving to making one determination together and then moving something as an actual project into the review process. So make your voices heard tonight, bring in the feedback, and we'll keep going from there. And with that, I'll turn it over to Bob.
Thanks, Michael. So again, my name is Bob Bull. I'm a principal with the Smith Group here in Washington, D.C., and we are the architects and engineers for the Montgomery College Math and Science Building. So one thing I wanted to point out on the schedule too, as Michael was saying, we're on October 2nd here. We have one more meeting in 2 weeks to talk more about the design. You're going to see a very developed design already tonight in some of the later slides, around slide 110, 120. No, I'm just joking. We don't have quite that many. But the important thing to note is that we were going for mandatory referral after the 16th, October 16th. So that is a county requirement that we submit our design for their review and consideration. There will be opportunities to continue to engage after that point, and we're targeting the winter of 2019. But as Michael was saying also, this is a really important stage in the process to really glean the important feedback that you guys all have, and so that we can inform the design with those important comments. So we're at a really critical stage between this meeting and the next meeting. So hopefully you guys are all on board with us, and we can make it a fulfilling process and rewarding for both sides. So moving into the core of the presentation here, one of the comments that we heard at the last meeting was that maybe some of our tree information was not as accurate as it needed to be, and we did find out that that was true. There were 3 trees missing from the survey, so we got the civil engineers back out and to confirm which trees were missed when they did the original survey, and it was these 3 pine trees. We've gone ahead and updated our base information, and all the renderings and images that you'll see from this point forward will include those 3 trees. There was also a question about where is the site context information coming from? We go through this kind of exercise quite frequently with campuses and other clients with very complex context situations. So we've gone through and done a pretty exhaustive due diligence on the existing buildings on the campus and the surrounding area, and compiled all that information into the 3-dimensional tools that we're using to represent the designs that we're sharing with you tonight. So there's a very high level of accuracy that is underlying a lot of the imagery that you're seeing. And it comes from a lot of this very detailed data from the building construction drawings, detailed surveys that we're getting from the civil and landscape team, and other records that we get from the county and other agencies. So we can really trust and be assured that the information that you're seeing is actually depicting the size, mass, bulk, and design that we're proposing. And it should look very much like what you're seeing on the screen tonight. So we'll do a little recap of the last design review that we had on September 11th. And just to reiterate, there's a couple slides here that we're going to just move through pretty quickly, but there were some original design directives that we started this process with, and just to review them in summary very quickly, but we wanted to keep the current setback of existing Falcon Hall, so that's basically that 110-foot setback from the curb line of Tacoma Avenue. We wanted to protect the park-like green space on Tacoma Avenue, so that's the triangular area that I was talking about a few slides ago, where the existing trees and landscape are staying intact. Minimize the windows along Tacoma Avenue, so basically from the vantage point along Tacoma Avenue, minimize any kind of light trespass that would occur in that area. Ensure that height is no more than 2 stories on Tacoma Avenue. So this is where we developed our own sort of methodology for determining how you would measure the height. So we established the 70-foot setback from the 110-foot setback. That is that sort of 2-story building zone that we're limiting the current design to. Take advantage of the existing topography to minimize the perceived height. One of the interesting site characteristics is that there's a 10-foot grade change from Fenton Street down to the tennis court area, and we are using that to basically conceal 1 story of the building height in the concepts that we're sharing with you previously and tonight. Locate the height of the rooftop units away from Tacoma Avenue. So essentially, all the mechanical equipment would be organized such that it is close to Fenton Street and away from the residences on Tacoma Avenue, and then minimize or maximize the building width and lower the height. And obviously, we are the architects that were hired, so we don't really need to talk about that anymore. One important aspect of this that we will reiterate over and over again, that this is the new age of math and science. We're doing a building for the future, not for the past. There are specific design elements and components that must find their way into this building that many of us that went to school 20 or 30 years ago wouldn't recognize, but they're critical to the success of this program going forward. A lot of it has to do with active learning, team-based work, engagement with not only students and faculty, but outside community members within the building. So all of these elements sort of drive a different kind of planning model than what you all and what we may all be reflecting back of from 10, 20 years ago. Another very important aspect is sustainability. We in the architecture and engineering industry use LEED often to measure the sustainability of our projects. This project will be at least LEED Silver as measured by the U.S. Green Building Council. We will begin to see, actually in some of the images tonight, some of the first elements of that sort of sustainability approach manifesting itself within the design of the concepts that we'll be showing. And then a very quick summary of what the program for the building is. These are 2-scale blocks of all the elements that go within the building. The color represents the different type uses within the spaces. All the big yellow and orange blocks are the laboratory spaces. All the blue blocks are the office spaces. And there are a few other kinds of spaces that support the building with administration and other functions. But essentially, you can tell very quickly that this is a lab building. It's going to have a lot of laboratories in it and some other supporting elements around that. But for most intents and purposes, it is a lab building. So here's some of the new information that we'll begin to share with you in this part of the presentation. As we begin to look at the architecture and the massing of the building and also the materiality of the building, one thing that we often find is very important is just understanding what is the current perception of the existing buildings that are on the site. Even that they're going away, it's important to understand that there is a sensibility of these buildings that has been part of the neighborhood for a very long time. And understanding how that relates to the existing community is an important part about how we want to use that as a departure point for the new building. So obviously Falcon Hall has a very interesting mass. We can argue about whether it's successful or not, but it does have a very diminished presence off of Tacoma Avenue, and I think that's one of the important aspects that we've heard from most of the neighborhood constituents that is needs to be maintained going forward. And then there are specific elements within Science South, its window walls and its massing and form expressing the planetarium, where unique aspects of that we may find ourselves leaning on a little bit and leveraging in some of the concepts that we develop going forward. An important aspect to also understand is that this site on the campus, and here's the site that we're challenged with right here, between Fenton Street and Tacoma, has 2 distinct faces. One organized and oriented along Fenton Street and the other along Tacoma Avenue. The general architectural context as you come south down Fenton Avenue is distinctly different than what you see as you come west on Tacoma Avenue. So north on Fenton, you have the Nunley Center, which is 217 feet wide. And then you have Science North, which is 280 feet wide, which are significantly long buildings, and they have a very significant presence as you approach from the north going south. So that is represented by an organizational rectangle here. And then if you look at the other buildings from the east, the Resource Center, the Commons, Pavilion number 3, and also the residential context, there's a distinct departure in the massing and the organization of those buildings. There's less of a linear rectangular organization, more of a square organization with dimensions more like 150 or 165 or 148 feet, which is radically different than what you see on Fenton Street. So what we're beginning to understand is that there is a sort of unification of those two sensibilities on this project site. There's a convergence of this longer organization along Fenton and this smaller scale, more squarish organization coming off of Tacoma Avenue. And again, this is very sympathetic with some of the residential character that you see across Tacoma and across New York. So you'll start to see how that is informing and influencing the design as we develop the architecture a little bit further. So looking further into that existing context, you'll see some of the materiality from the existing campus and the neighborhood tends to tie together already pretty well. There's a pretty strong dominance of brick on the existing campus and earth tones. So when we look at the Nunley Center, there's a lot of beige and brown brick. When you look at the Commons, there's a lot of beige or brown brick. And then Pavilion number 3, which is one of the more recent constructions on campus, or just off campus in that it's on the other side of New York Avenue, uses a terracotta tile that is very similar in coloration and tonality to some of the beige brick that you see elsewhere on campus. There are other elements that we're looking at too as we're understanding the campus, but that is looking across the street at what is comprising the material palette of the residential areas on the other side of Takoma Avenue. It's a radically different scale shift in the architecture, but there are elements that do tie across the street, and that's a lot of the landscaping, the native planting, the lush greenery. Those are the elements that we can use to really tie things together. There's also lots of stone walls, garden walls, and things like that that are elements that have a very residential quality to them, but that translate very well to an institutional campus setting. And you'll hopefully see how that works in some of the future slides as we look at some of the concepts. Sorry. No, I got it. There are a couple other materials on campus that we'd like to note at this point. On Science North and the Resource Center, there are sloped metal roofs with standing seams. So that's may find its way in some of the material palettes that we present at a later date. But there's also what we call window wall or a curtain wall, which are large assemblies of glass and aluminum to maximize transparency where it's important on particular parts of the building facade, essentially facing campus in this particular situation. So in summary, this is what we like to refer as like our material palette or material collage. What this is meant to represent is what is that tonality of that material experience when you're on campus or when you're in the adjacent neighborhood that is the starting point for beginning to think about the materialization of this building. How will it be rendered in different materials? What will we use as a guidebook to pick those materials, and what colors should we be looking at to find something that really works well within the existing context? So we're looking at brick in native colors, so or earth tone colors. We're looking at, again, terracotta, which could also be in a brick tone. There are some elements of natural wood that we might find in the new building that are evident in Pavilion 3. As we were talking about before, the curtain wall or window expanses that you see in several of the buildings on the existing campus. Also on this building, like how is that curtain wall treated? One of the particular advantages to this particular glass assembly is its screening. There's a material called ceramic frit applied to the glass that helps reduce the solar gain in this particular instance. And again, the sloped metal roofs and site context, so the lush greenery and landscaping, and potentially some stone articulation and site walls. One of the things that We are not really going to hit on too hard is the landscape design tonight. That will be in hopefully the next meeting. We'll understand more about how the setting for this new building will fit very well into the campus. Is there a question? Yeah. Mm-hmm. Sure. So, okay, that's a fair criticism. No, trust me, we're not excited about the glass, especially facing west on Nunley. So, well, I think when you'll see the options as we present them, we don't really represent a similar effect. Okay, so summarizing what we presented on September 11th, the three schemes, we had concept 2, which we were referring to as rotated pavilion, concept 3, which we are referring to as distributed bars, and then we introduced a new scheme or a new concept, which was 2.5, which was at that point untitled, which was a hybrid between concept 2 and concept 3. The big difference with concept 3 was it was significantly taller on Fenton Street. And we heard pretty unanimously that that one was just not preferred because of that particular presence on Fenton Street and the way it dominated that part of the neighborhood. Even though it was facing the tracks, it just didn't feel like it fit in. So we've eliminated that option. And so we're really moving forward with option concept 2 and concept 2.5. So here's some new images. We'll go through each one of these options, but here Concept 2 and Concept 2.5, we've renamed Concept 2.5 distributed bars. One of the things that was really important about the distributed bar scheme or option was that it tried to break down the scale of the mass by using different bar-like elements to reduce the presence of the building and the scale. So just to make it very confusing going forward, we're going to say 2.5 is now the new distributed bar scheme. So we'll go through the plans very quickly in a very similar format that we did before, building up from the ground up to the upper elevations. So as we were talking about earlier, there's a 10-foot cross slope from Fenton Street down to the campus. So this first floor is essentially below grade. That you can walk in and enter here from the campus, but from here it's almost completely below grade. It does become partially below grade as you rotate around the building on the south side. So what you're seeing here in the white blocks are those lab spaces. So all the labs are organized to be adjacent to or parallel with Fenton Street. And then some of the less lab-like or more student-oriented facilities like the Learning Center, the planetarium, more public-oriented, are all organized to be directly off the campus quad or campus side of the concept. So moving up, we've added one story on top of this model. So you'll see the planetarium is a two-story element, begins to show that two-story drum-like shape coming up through the building mass. And again, more labs organized on the Fenton Street side and the Student Resource Center on the campus side. Oh, I will note too, on this upper level is where you can walk right in from the north side of campus. So this is the primary campus entry from the north coming to the south. So entry here, and then there is an entry on the drop-off that we reviewed at the last meeting coming in off of Fenton where the red arrow is there. And then as we go up one additional story, more labs on the Fenton Street side. And here this is a completed roof plane or pavilion, and thus the name rotated pavilion. And on top of that pavilion, you'll see what we're beginning to show is a greenhouse, which is part of the program with the academic portion of the program. So that would be manifested as a glass traditional greenhouse type shape sitting on top of the roof there. And here's the completed building. Again, what you're seeing here is kind of the bones of the building in almost X-ray form. But there's a new organization here that we didn't share last time that will reinforce with this slide and a few other slides later in the deck, in that we're organizing all of the mechanical equipment on a area of a rectangular bar closer to the center of the campus, so that we aren't using any of the space that's directly adjacent to Fenton Street for the mechanical equipment, which is really the tallest part of the building mass. So that moves away from the center of, or from the edge of Fenton, closer to the center of campus. And then all of the rooftop space that is directly off of Fenton Street, what we're showing here is a photovoltaic array that would be used on the rooftop to be almost like a science on display. So there are examples of photovoltaic arrays elsewhere on campus. There's one just right across the street here. This is meant to be a very intentional assembly of those photovoltaic arrays in such a way that it does contribute to the character of the building and give it an architectural expression that is commensurate with the program that's within it. So again, science revealing itself on the outside of the building, not just on the inside, or outside, not just on the inside. Comparing this concept too with what we saw on the 11th. So what was shown on the 11th is on the left side. What we're sharing with you tonight is on the right side. So you can see the organizational element, which is the lower pavilion, is slightly different. This is primarily the reflection of some arm wrestling we're doing with the program. It's been tightened up and cleaned up some, so this became a much simpler shape. You can see the planetarium is completely concealed within that rotated pavilion, but it does have a small little bit of an expression poking up above the roof. There's that greenhouse that I mentioned earlier, and that organizational concept of the mechanical space on the center bar, and then a photovoltaic array on the outer bar closer to Fenton. And we thought that some of the very effective comparisons that we were sharing earlier, which is this is the existing assembly of Science South and Falcon Hall, and this is what it would look like if you overlaid the proposed design with the existing buildings. And you can see there's a very similar diminished presence of the building from Tacoma Avenue, with the majority of the building mass organized along Fenton. The building height as proposed here is like 39 feet compared to 24.8 of existing Falcon Hall, but Falcon Hall has a very unique shape to it, so it does rise up quite a bit as you get beyond that element. So you can see the building is actually lower when you get to that upper portion of Falcon Hall. Looking at it from above, we've added, per request, a bunch of dimensions around the building to give it some clarity. This comes with the caveat that we are still very early in the design phase. These numbers will change a little bit. We think these are very good, rounded guesses as to what the size of the building will be. It will evolve. They will grow by fractions of feet, maybe a couple feet here and there, but for the most part, we think this represents a very safe guess as to what the actual dimensions would be. Yes? So, okay, 39 feet as measured from grade for the 2 stories that you see on campus. Right now, the grade changes. So this is lower than here, right? So this slopes up. So there's 24.8 exposed from Falcon Hall at its tallest point off, at this point closest to Tacoma Avenue. And then as you move up, I don't know exactly what the dimension is. What, from here to here is what, another 10 feet? 7 to 10. So this is like 34 feet here, but it's measured from a different point. So that's why you're not seeing it, the new building eclipsing or above that existing roof line. Yes, sir.
Can you tell us how much higher the new building would be than that girder structure that's currently on Falcon Hall?
That looks,
The top of the girder is 57'9" quad.
yeah.
They're probably about 5 feet.
Yeah, I would guess it looks like about 5 feet right there. You can see just barely. I can't even hold the laser pointer close enough to, but it's basically above the girder, probably about 5 feet would be our guess.
Are the array of solar panels higher than the array of mechanical?
No, they're below, and you'll see some images later that represent that. Yeah, they're well below. Yeah.
Okay, so just to be kind of clear what I'm looking at, when I look at your previous concept sheet, the building height is 43 feet. That's the building height.
It depends upon from where you're measuring. Which one are you looking at?
Well,
Okay, but it's important to understand that the topography changes as you go around.
And I'm not quite clear where you're getting 53 feet now, because now all of a sudden it's taller, and are you measuring, is that not the actual building height, or is that, what is on top of that?
So you're measuring from the top of this is the top of the screen wall. No, it has not. It is not any taller than it was before. Yeah, so it's important to keep in mind that the topography changes as you move around the building. So as the building mass moves around, the measuring point moves as well.
I think I see you're not measuring it from the same place as your previous drawing. Okay, I see that now.
Okay. We're happy to, if you have specific questions on height, we can drill into this and be very specific to compare to whatever you're looking at. No. No, this is not meant to raise the height of the building in any way, and I think as we show more of the eye level views, you'll see that we're actually trying to bring it down as much as we can. Okay, we reviewed this with the dimensions, and here this diagram begins to try to explain that sort of layering of the bars that I was talking about earlier. So the lighter gray bar that is immediately off of Fenton Street is where the photovoltaic arrays were. The darker gray bar is where all the mechanical equipment would be. You're not really sensing it here, but you'll see in the images in a minute that this bar is basically where all the mechanical equipment is taller than this bar. So here's the view from Tacoma and Fenton Street. We had shared this view previously. It shows most of the trees screened or screening the building, but just to reveal what would happen if we took the trees away, you'll see that that smaller bar or shorter bar on Fenton is here, and here's that taller bar towards the center of the site. One organizing element that we're also using as we begin to modify and develop the mass of the building is a horizontal base. Now, this is meant to be reminiscent of some of those garden walls or those site walls that we find in the neighborhood that really work very well from an architectural point of view to reduce bulk, reduce mass of the building. So if you sort of perceive this as a base or plinth with 3 elements resting on top, you've got the 2 lab bars and then the pavilion piece, which is this diminished, more glass and metallic piece sitting on top of that base. Again, mostly screened behind the trees off of Tacoma Avenue. So this is a similar view, but just rotated a little bit around. Again, we have a key plan down here in the right-hand corner. So you're seeing, again, the building facade on Fenton. You'll begin to see a bit of that photovoltaic array peeking up in this image. You'll see it a little bit more in the later images. And then here's that central bar with most of the mechanical equipment, concealing it from some of the primary view from the major public areas because it is sort of in the center of the building mass. Yeah.
The heights, as we're looking at them, you don't have them on there. It'd be helpful to actually put them on those slides. But the height, can you give heights of the 2 buildings that we're looking at?
So it depends upon where you're measuring from. So if we go back, so 53 feet as measured here to the top of that screen wall. And then the 39 feet here, 40 feet from the north side. And actually that's measuring Falcon, or Science North, right? Science South. This is the same height that we had showed last time. Yes. So this is the same height that we were showing here originally. This is all mechanical equipment that's above the building. It's all necessary to support the lab function within the building and the HVAC with the building. Yeah. Right. Correct. Yeah, so this is a screen wall that is concealing the mechanical equipment that is up above that level.
I don't see a wall there,
Yeah,
contrast with what you showed before. And that's
it's different.
very big.
Okay.
That's way big for a residential neighborhood scale.
Just want to remind everyone we'll have time to get all the comments after this. We've got 60 more slides, so I want to make sure we get to that portion of the meeting. Okay, so rotating around, we're looking at Fenton Street. So this is looking at the mass of the building as it presents itself on Fenton. One of the issues that we heard at the last meeting was that reducing the height of the building here was an important characteristic that we're challenged with. So that was why much of the mass of the building and the mechanical equipment was pushed to the central bar, so to bring this part of the building down as much as possible. We've also introduced this horizontal element off of Fenton to, again, make this facade more humanizing or human scale, to have an articulation of that base that wraps around along Fenton that, again, reduces the perceived height. So what you're seeing here are the windows into the labs. There's an articulation of shading on the windows. We talked about earlier about how this western-facing facade is a primary solar gain orientation, so incorporating as much solar screening elements as we can into the western-facing facade is an important aspect. Yeah? This is a loading dock, yes. Yeah, and there's also, we talked about the drop-off off of Fenton Street so that you can barely see, but there's a bit of a stair and a doorway peeking out around that building element there. Okay, well, just to be clear, that was contradictory from what we heard at the last meeting. We're just reflecting the feedback we got last
Yeah.
time, so if you want to provide new feedback, let's make sure we document that.
We will, because in our group, that certainly wasn't.
Right, we've got a lot of stuff to get through. If we could hold some of the comments for that, that would be super helpful.
But there were 4 groups.
Right.
Yeah. Okay, so again, moving up on Fenton, again, here's the building on Fenton Street and its alignment with Science North and that lower scale building element poking out, sort of bringing down the scale of the mass of the building on Fenton. This is the view looking from Tacoma Avenue up the existing drive, and here you'll see the central building element there with that articulated base or plinth that we were talking about earlier. One of the things that we were really sensitive to here was trying to diminish the presence of the building as viewed from Tacoma Avenue. This element is the closest part that you would see from the neighborhood, and making this, again, as grounded and solid as possible was one of the architectural elements that we tried to reinforce, and then dematerializing the pavilion piece that is right above it was one of the aspects of the architectural design that we thought would, again, diminish its presence within the neighborhood and try to ground the building and make it look as small and relatable in scale to some of the smaller buildings that are adjacent and within the context of the neighborhood. And you can see the relationship that ties to the commons immediately adjacent to it. Here's a view from New York Avenue in Tacoma. There is, here's the Commons building. You can see the new building poking up beyond. Regardless of where this mechanical equipment would be, whether it was on Fenton or on the central bar where we're showing it, this would essentially be the same view. Here's a view from New York Avenue with all the existing trees, and then the embellished view, removing the trees and screening them out. So here you'll see again that articulated base, an entry from the lower campus level, a lighter dematerialized building element sitting on top of that base, and then that mechanical screen above. You can see a bit of the greenhouse also sitting on the roof plane of the rotated pavilion. Yeah.
Does it make a difference whether the solar arrays are on the part facing factory versus the other?
The orientation is better on the west side, yes. So where they are currently shown has the most desired effect.
I'm sorry, what's the desired effect in terms of,
Solar power producing.
then if they were to shift it to the middle, right?
If they were in the middle and the taller building element was here, then the taller building element would shield them for the majority of the day, and they'd be in shadow, and they wouldn't work. Okay, so in summary, again, the dimensions for the concept. The important takeaway is that the 160-foot setback from Tacoma Avenue, we are significantly further setback than what we had originally committed to. That orange zone here was that magical setback line, so considerably more than that. And then we are only doing a 2-story building element right up until that additional 70-foot setback after the 110 that we were talking about earlier. So moving on to concept 2.5, very similar series of slides here where we build up from the ground, first level submerged below grade, entry off campus, 70-foot setback from Fenton, and 160-foot setback off of Tacoma. Here the planetarium you'll see is embedded within the building there, but as we move up, it becomes a standalone element that breaks free from the building mass. And the greenhouse also becomes an articulated building element on the campus side of the facade that faces the quad. The lab portion of the building is similarly organized in this concept off of Fenton Street with 2 layered bars. Moving up 1 additional story, again, the planetarium breaks down the mass with a cylindrical shape. We looked at a variety of different shapes. One of the things that really had the least sort of imposing presence on the neighborhood was the drum shape, because it does sort of wrap around and sort of eliminates the corners. And it is, as we talked about earlier, one of the only programmatic elements that does not require windows, so there would be less light emitting from it and potentially disrupting the neighborhood. And then the completed building mass. So the important aspect where this one is different is it's lower on the plinth part here, but most of that building area has been shifted to an multi-story element here that represents a taller portion of the building on the campus side. This concept is essentially the same as concept 2. So the 2 bars that are organized off of Fenton with mechanical space and the photovoltaic arrays are essentially the same. So the comparison between what we showed on September 11th and what you're seeing today, here's what we showed on September 11th, here's what we're showing today. The primary difference is, again, that lower bar on Fenton, the mechanical space in the middle, and the slight difference in how the plinth and the planetarium engage each other, and then somewhat different massing in the center of the building, again, related to us trying to program out some of the internal functions within the building, getting them to fit in a reasonable way within the footprint that we've established. And again, the comparison of the option 2.5 with the existing Falcon Hall. And here you'll see, again, the very diminished presence of the building as viewed from Tacoma, but a much larger presence of the building pushed towards Fenton Street. Here we have a 55-foot building elevation from the campus, and here we're saying 53 as measured from that corner up to the, look, is that to the screen wall? Yeah, I think that was intended to be from the screen wall on that dimension there. And then the overview, again, with dimensions and plan. The big difference, again, here is that all the building elements as they're organized on the campus side are slightly different. Some of the mass has been reduced here and pushed into a taller building mass here, and that reveals the planetarium to an articulated building element as viewed from Takoma Avenue. One of the important aspects that allows us to do is that there is a scale and shape and size relationship between the planetarium and the residential structures across the street that is immediately relatable. There's also some scale similarities with this plinth and the commons and the resource center that begin to tie together all of these elements as we were talking about with some of those diagrams earlier in the presentation. Yes?
There's one issue I have with planetarium. It's 60 foot in diameter. It was a 60-foot box before. But if we're going to have a 55-foot planetarium dome in there, it doesn't leave much room.
So we've got some homework to do on the planetarium. We're still at early days. We'll have to do some very detailed technical work to determine the actual dimensions.
Williams has no problem with one of these 2.5-foot bricks. I do. I think
Sure. Okay, so I think we actually have a planetarium expert on our team that's going to guide us through some of those key metrics that need to be developed as the design gets more advanced. So, you know, this 60-foot dimension, again, is our rough guess right now. We may have to adjust that as we go forward, as we learn more details. Yeah.
This somewhat relates to the planetarium placement, but an area there that's 142 feet long,
Yes.
that's, I believe, 3 stories.
Yeah.
And if you were to extend that toward basically level, even with the end of the planetarium, the corner right there, I guess.
So you extend it across, yeah.
If you were to do that, would you be able to keep it 2 stories?
Keep which to 2
In
stories?
other words, that 142 length way, if that were to extend toward the front of the building all the way,
Yeah.
so it sort of, it came all the way through on the other side of the planetarium, as the
Yeah.
center portion.
That's essentially concept 2. That's what it does. Yeah, we have some comparison slides that you'll see that, but essentially the difference between concept 2.5 and concept 2 is one story has been removed in this concept and then aggregated together to create that taller building element. If you were to take this building element and spread it out to be lower here, that's concept 2. Okay, so looking at the organizational diagram, again, there's like 2 distinct bars off of Fenton Street. There's a corridor that connect the 2. And again, there's a slightly different play with the building elements as they face the campus, the planetarium being part of that, and then this lab office bar that faces the campus is a little bit taller in that particular section. But there is a significant step down towards Tacoma Avenue and the residential community. Oh, sorry.
One difference with concept 2 would be that you would still have some sort of standalone structure for the planetarium rather than it being embedded within the entire structure. You would still have some portion of it separate, and that would help break up some square mass.
Yeah, so you probably could do it. I mean, it would take probably pushing the planetarium closer to Tacoma Avenue to get it to be separate and distinct. Right, right. I mean, you could come up with some kind of alternative similar to that if that was a preferred direction, yeah. Okay, so again, looking at the eye-level views, Tacoma Avenue and Fenton Street with the trees, and here without the trees, you'll see with this concept we have begun to articulate the mass and the bar on the Fenton Street side a little bit differently. If you remember back a few presentations ago, we talked a lot about how the solar orientation was very important on this particular part of the building. So you'll see some very animated screening devices architecturally that we're using to help accomplish that screening. This is the building central bar that we were talking about. You can see the screen wall and the mechanical equipment beyond. We can dematerialize this a lot from an architectural point of view by making these openings as transparent as possible. We can also probably, if height is a big problem, we can begin to bring it down. What the trick is to see if we can bring it down without revealing the mechanical equipment that's beyond. And that's a 3-dimensional exercise that we can do to try to reduce the visible height of the screen wall. Yeah, it's the challenge that we're having right now is that we would quickly run out of space for the equipment we need to put up there. That's the challenge.
Is there a reason why all the mechanicals have to be on top of one of the bars? For example, the southern third of the mechanicals on that central bar were located on the other bar that's along Fenton, but toward the back of the northern end.
Right.
I don't know if that would work.
It could work. I mean, there's a sort of architectural purity to like keeping the clarity of how everything is organized. But yeah, we could have mechanical equipment on the other side as well. Okay, so here again, I'll point out a few things. One is that similar organizing element of the horizontal base that is beginning to be used to reduce the perceived presence or mass of the building. Here you'll see that planetarium articulated as a drum, and here with some kind of masonry or brick veneer to make it as attractive as possible, but again, reinforcing the fact that it does not have any windows, it does not have an opportunity for light penetration into the neighborhood. And from this view, you begin to see how that base breaks down and becomes more of an entry from the campus side as you get around the corner. Then looking at the view from Fenton Street, again, this is the looking across from the bike trail closest to the railroad tracks, that central piece where the mechanical equipment is. And again, you can see that is our estimate as to where the top of the mechanical equipment is. There could be an exercise, like I was saying a minute ago, where we actually look at reducing and bringing that top level down somewhat to reduce the perceived height of this element. And then here you're seeing, again, that shading alternative to the building as it presents itself along Fenton Street. And again, from the loading dock view on Fenton, we're using a very similar architectural idea on how to break down the scale with a smaller building element that projects out from the building face onto the public area on Fenton Street with the larger lab block above it. And again, a very different kind of horizontal shading articulation here that is different from the concept you saw in the last scheme. And then looking at it further up Fenton Street, again, you can sort of see some of those photovoltaic arrays poking up above it as you get further away from the building. And then the view looking up the existing drive off of Tacoma. Again, the planetarium becoming a focal element there as this opaque drum-like shape that will house that primary activity. And then seeing the two-story block of labs here with the mechanical equipment above, and the portion of the taller element of labs and offices right off the campus and setting in the background there. The view from further down Takoma Avenue past New York, again, you're seeing a bit of that building element poking out above the Nunley Center. I'm sorry, the Commons. And then looking at the building from New York Avenue with the trees, and then without the trees. So here you see the big difference in that this, in option 2, is the two-story element gets removed from here and stacked on top of that other one-story element there, and you're getting a bit of that photovoltaic array peeking out from above the roof from there. And again, the summary slide looking at how the building is organized off of Fenton Street, the layered bars, the rotated office lab component off the campus, the separate planetarium element, and the base that is facing Takoma Avenue. Again, a significant reduced presence of the building off of Takoma Avenue, especially in that the original commitment was to have a setback closer to 110 feet, which is 50 feet further towards Takoma Avenue. All right, so now we're going to go through some very quick form comparisons. So the rotated pavilion on the left and distributed bars on the right. So option 2 on the left, option 2.5 on the right. And here they are side by side as they relate to the existing Falcon Hall. And here they are in the overview. And then the view from Takoma Avenue. And then with 2.5 from Takoma Avenue, I'll go back one. So here you can see the big difference is really essentially right here, where you have that one-story element sitting on top of the base. Here that one-story element goes away and the planetarium is revealed, but the building mass beyond grows to accommodate the difference in area. And then side by side. When we get into the breakout groups, these images are going to be the basis of that sort of presentation, so you'll be able to see these side by side in the print. Okay. So perspectives are never to scale because they're relative to perspective. All the plan drawings are to scale, and that's why we put the dimensions on them. Perspectives are not to scale, just like photographs are not to scale.
But they are relative to the scale to the components, yeah.
Right, they're relative to each other.
Yes, exactly. How high, let's
Yeah. So we're guessing it's 60 feet tall. So Nunley is significantly taller.
There's a question every.
Yeah, there's many questions actually. Yeah.
I had a question on, you had brought up trying to reduce the light coming out to the neighborhood.
Yeah.
And so was that, I didn't remember in our versions of that being a principle. Because honestly, like, from a person who lives across that from there, this feels like a little more dark and ominous on the right than the left. And I was just wondering if that was, was it a perspective you thought the neighborhood wanted?
It was clearly articulated to minimize the windows off of Takoma Avenue. That was one of the primary design objectives that we heard from the neighborhood group.
Is there a comparison between concept 2 and concept 2.5 slide that shows the New York Avenue?
Yeah, we're getting there.
So why are the layout is different? Why are the, I guess, the facade, if you want to call it that,
So we're still in a very conceptual stage, and so we're still experimenting with architectural expression. This is actually the first meeting where we shared any architectural expression. So that's part of the idea with tonight's meeting, is to get some commentary on what is good and bad about each architectural expression. Are there things that people like or dislike about either one? So they're intentionally meant to be different, but there are elements from either one that could be applied to each other. If that makes sense.
Why are the windows darker in the middle one on the left versus the right?
In the middle one.
And the middle is dark here.
So here versus here.
Yeah.
I think that's,
It does.
the part there's a strip that's darker, and there's a lighter part, the darker part.
yeah, so there's less window here. So that's actually another material. It's not glass. Yeah. Okay, so let's move through looking at the Fenton Street side. So here it is, option 2, option 2.5, and here you can begin to see how the transparent window portion is that vertical element there. And then the side-by-side comparison. And you can see there's a couple of different things that we're experimenting with. One is like how the screen wall is articulated on the top level, and how we might handle that differently depending upon which option we go with. There's a million other options we could study too that would further potentially dematerialize the presence of that wall. And then the view from Fenton at the loading dock, the two different options, and then the side-by-side between the two. And again, this facade is really being driven by a solar shading concern that we're trying to minimize the heat load within the laboratory spaces. And then further up Fenton, as you approach, again, showing the relationship contextually to the other buildings along Fenton Street. And then with 2.5 and the different shading approach. And then the two side-by-side. And then side-by-side from Takoma Avenue. And then side-by-side. And then from Takoma Avenue past New York. You can see these two are very similar, barely a difference there. Shading elements from the Tacoma. So that is something we talked about. There is a shade shown on the top of the, if I can go back that far. So there is a shade shown here. There are obviously, there are shades shown back here on these windows. These are set back from these here. So there aren't many windows here, but there is a projected shading device around the edge of that window. You can't really see it very well, but you can see the shadow of it there. Pardon me? Definitely. Oh, okay. So the laboratory venting occurs in this mechanical space. It's actually organized towards the northern end of this penthouse space. No, it goes straight up, and it's, we talked about this at the previous meeting where there's an entrainment expert on our team that studies this specifically. They have built a model basically to study the air patterns around the existing site and the new building. And they've already done a conceptual review of the site, and they've recommended putting the exhaust towards the northern end of the Fenton Street side. And that's currently where we're showing it. So right now it's just conceptual. There will be a more detailed report at some point. Okay, well, we can work with the university on that, or with the college. Okay, so, going forward, we reviewed this. So here's the view from New York Avenue, and then for concept 2.5, and then the side-by-side comparison. And that's it. 110 slides, 95 slides.
95. Okay, any general questions for Bob before we jump in? Because I want to get to small groups, but any overall questions?
Very briefly, as a resident member of the neighborhood, I think our focus has been all along on putting as much mass on Fenton as possible. I've been at the other Charrettes, but unfortunately, this is the 9/11 one. I'm just curious, from who was the input that to lower the height?
So on concept 3, we had quite a bit of additional building mass, a whole additional story on Fenton. And it was universally from all of the groups that I had heard from, and I thought pretty generally that that was too much, that there was too much building mass on Fenton, that the building was too tall. That's why we eliminated that option. So these concepts take that one step further. Sir.
Your idea of distributed bars disappear if the mechanicals were located on both portions of first and second bars of the northern campus rather than spanning all the way closer to Fifth Avenue. I mean, right now you've got one hall panel of solar panels, one bar, solar panels, one hall bar of mechanicals. And what the neighbors are going to want mechanicals pushed farther away from their homes, and both the height and the noise, whatever noise there is, there will be some noise, and the air is blown out. You're going to want to put it towards the tracks, towards Fenton Avenue. And so, frankly, that view from Fenton Avenue is not a view anyone's going to see unless they're in a car driving by. So, I think that that's going to be a key right here.
Yeah.
Great. So I want to make sure we're capturing these. My team has written down all the comments we heard today, so we've got those, but I want to break us up into some smaller groups so we can jump into these with the architects. So we have 4 groups today. You have a number on your name tag that'll break you up into a different group. So number 1 is going to meet in the lobby, number 2 in the art gallery, number 3 in the back corner here, and number 4 up here in the front. So let's break up into groups. We'll have a facilitator, a note taker, and an architect at each one, and then we'll come back together. Thank you. You guys ready to get started? Yes. Perfect. Groups are already figuring out what to do. We're going to try and give the top 3 or so points from what your group talked about so we can capture them, and we'll start with group 1.
As the representative from group 1, there were a couple of points that we wanted to make that we felt were consistent among most of us. One of which is that the building height is still a concern. The central bar, as it reaches the exterior of the building facing Tacoma, is still tall and is still a concern to many people. The materials of stone were well received, though also the blandness of the palette was less received. Color could be introduced. The planetarium, some people felt that the drum above the platform of 2.5 was good. Some people felt that hiding it was good. Some mixed feelings on that. The 2.5 materials along the Fenton side, the long horizontal members, were universally well received, and the vertical punched openings of 2 were not well received. The skylight hole in the middle of the building, everyone thought was a good idea, and they didn't like the 70s style brutalism of the center bar.
Thank you. Thank you, Team 1. Team 2. Team 2, come on down. You have a high bar to live up to after Team 1. So.
All right. So for team 2 is also kind of like mixed kind of feelings about concept 2 and 2.5. Some preferred the facade along Tacoma for concept 2 and preferred the overall height. For 2.5, we heard that the layout is nice. You can see the roundness of the auditorium that helps to break up the space. Other points that we heard is that the maximum height should be along Fenton. The middle bar should not be made from the same materials as the other two, and that break up the design more is one thing that we heard as well, so that the building won't look like it belongs on Pennsylvania Avenue. And then another idea is to put plant or solar panels in front of the mechanicals on the mechanical level to hide it a little bit.
Good job. Thank you, Group 2. Group 3.
Concise.
I would humbly submit that Group 3 was the best group. Would you agree, Perry? Perfect.
Yes, we definitely will. Chris, did you just turn this microphone off? Okay. Actually, what Group 1 concluded is almost identical to what Group 3 concluded. Right? So I don't even know if there's anything to point out that was different. We also liked the stone wall. We liked the verticality of what was going on in 2.5. We didn't like the horizontal aspect so much, and this is mostly on the Fenton Street side. There was some concern by neighbors that there weren't enough trees, but we understand that trees are coming and that we needed to somehow block the New York Avenue view of that side more. I think there was a mixture of feeling about the planetarium. Some thought it was more interesting seeing it. Some thought it was jumped out at you, and in fact was referred to as, I believe, seeing a clown on the street. I believe was the expression, which was something someone said she's hiding back there behind a sign. But I think that's about it. I mean, as I say, a lot of what you said, we agree with.
Thank you. Appreciate it. And Group 4.
Thanks. So Group 4 also was concerned that the height of the middle bar was too high. And so we explored discussed two options. One was to take all the mechanicals and put them on the bar that is along Fenton Avenue as one option. And the other option was to maybe take half of the mechanicals from the middle bar, the southern half, and put them towards the back half of the outside bar along Fenton, so that you've got maybe 2 rows of mechanicals, and then you wouldn't have, you place some portion of those solar voltaics with mechanicals along Fenton. The general concern was that you know, nobody wants something super tall on Fenton, but if you're going to have to go high on Fenton, rather than go high closer to the community and the view from Tacoma Avenue. There was discussion of a green roof and whether that's going to be done or not. I think that was just tabled for a later consideration by the architects, but I think we expressed that would be nice to see. We talked about 2.5 and showing the observatorium, and I think they thought it was, some people liked it, some people didn't. It was just kind of a mixed bag in that regard. And then we talked a little bit about value engineering, and that we would want to make sure we have some certainty that all these nice design features, whichever is ultimately resolved, get locked up, so that when the value engineers come in, it's not all lost. And I think that's probably a concern the architect shares as well.
And the final point was we talked about whether or not there's a way to possibly shift the outer bar towards Fenton a little bit to grab some square footage and to allow the height of some of the buildings to be lowered as a result. And so there's some discussion about whether or not moving closer towards Fenton was possible or not, desirable or not, things of that sort. That's it.
Perfect. That is all the reports. Any last questions, comments? Sir. Mm-hmm. Middle bar?
The one that's up too high. If you have it painted darker than the other building, it will look smaller. If you paint something darker, it doesn't look, it doesn't stand out as much.
Mm-hmm. Thanks for the comment. We will make sure that one is written down. And what I'm hearing for the architects, which is kind of a cool thing to hear, is to have some fun with some of the materials here, like the stone. Let's look at the vertical and the colors. That's going to be a good thing to hear as we're going into the next round. Any other questions? We're going to reconvene on October 16th. And if you have any comments in the meantime, please email, call, make sure we get them. These comments will be recorded, feedback will be provided, and they'll all be put up online. Thanks again for another great meeting. What type of info? We'll have all of this. Yeah, we'll have all this online. The presentation won't go up before the meeting, largely because it takes the architect to explain it while we're here. Very good. Thank you all. Have a great and safe night. Bye.